Section 2.7, example 11, using a graphical approach to solve the absolute value inequalities. Given the equation y is equal to a negative 1 over 2 times the absolute value of 4x minus 5 plus 3, determine the x values for which y values are negative. So what we're looking at is the equation here. We already have y isolated, so they kind of give us a rule for what y could be, what y couldn't be. We're looking for y to be smaller than the rest of the graph. So negative values are when are when y is less than 0. So we just have to cap it off at that point. So 0 is greater than or equal to, it's going to be the biggest number it possibly can be at 0, greater than or equal to a negative 1 over 2, absolute value of 4x minus 5, and plus 3. I personally don't like working with our variable on the right side, so we're going to switch the signs and switch the sides of everything. So we have a negative 1 over 2, absolute value of 4x plus or minus 5, absolute value, plus 3 is now less than or equal to 0. Again, all of these numbers have to be negative or they have to be smaller than 0. Perfect. Everything makes sense so far. And let's just solve and see what we end up with. So from here we have negative 1 over, actually let's multiply both sides by a negative 2 just to get rid of these fractions. So multiplying both sides by a negative 2. Over on the left side, the 2's divide out on this first part. So we're left with negative times negative is positive. We have the absolute value of 4x minus 5. Negative 2 times 3 is going to be a negative 6. Since we multiplied by a negative number, we have the sign switching. So instead of less than, we have greater than now. And greater than 0 times 2 is still going to be 0. And now let's isolate that absolute value just to see what we're working with. So plus 6 on both sides. Absolute value of 4x minus 5 is greater than 6. Now, since we have a lot more possibility for this value to be greater than this value, we have like the positive n and also the negative n. We have to separate this into two different equations. So we have 4x minus 5 is greater than 6. And we also have the opposite end. 4x minus 5, change the sign. There we go. And then we just solve each of them individually. So over here, we're going to add 5 to both sides. 4x is equal to, or I'm sorry, greater than 11. Divide both sides by 4. X is greater than 11 over 4. And over here, plus 5 on both sides. 4x is less than negative 6 plus 5. It's going to be a negative 1. Divide both sides by 4. X is less than a negative 1 over 4. Let's graph these to see what we have. Negative 1 over 4, positive 11 over 4. We have open circles for both of them. And looking at this, x is greater than 11 over 4. So number is bigger than 11 over 4. So these numbers over here. And looking at this one, x is less than negative 1/4. So numbers smaller than negative 1 over 4. So those right there. And let's get our solution set. So our leftmost part is going to be that. So negative infinity up to, so up to here. A negative 1 over 4, open circle, so parentheses, then union, The next part of our solution set is going to be this part right here, 11 over 4 with a parentheses, comma, infinity. Infinities always have parentheses. That's our solution set. All right, but they did mention the graphical approach. So graphical approach, let's graph this. And here we go. This is our graph. So we did mention, let's see if I could get this side by side. Oh. So we mentioned this right here. We mentioned negative infinity up to negative 1/4. We could see that clearly here. So where our values are negative, so we're looking at numbers to the left of negative 1/4 or negative 0.25. So there's that. And also negative y values over here are numbers bigger than 11/4. And if we were to put 11/4 into a calculator, we'd get 2.75. So numbers bigger than 2.75, which are all of those right there. We could zoom out and kind of see everything a little bit better. So really cool there, really cool there. And that's how you could solve these problems using a graph. If you have any questions, please feel free to ask. Otherwise, bye.